Okay. I think I know who did. I will come collect the crackers. I think I know who they are. Okay. So here we go. What we're going to be looking at today, okay, is something called the triangle proportionality theorem. So again, we're on page 631, and we're looking at the triangle proportionality theorem. All right, now, this is a different set of ratios that we're going to be setting up here, and we want to be very careful when I teach this because it's kind of a different method, and so, we want to, well, you'll see when we get to it. So, how are we going to create this triangle proportionality theorem? Basically, we're going to ask the question, when a line parallel to one side of a triangle intersects the other two sides, how does it divide those sides? Okay, well, you can probably guess it's going to be proportionally because that's what we're talking about here. So what is that question really saying? So for example, we start with a triangle here, okay, and we pick a point, E here, on one of the sides of that triangle. It's just a random point E on the side there. Nope, it doesn't have to be the midpoint, it could be anywhere on the side. And if we take, from that point E, if we draw a line parallel to BC through point E, okay, so you see it right here. Here's a line parallel to, this line here, EF, is parallel to BC, and it's going through point E. I'll even draw that in there. Okay, we're going to create proportional pieces of our triangle there. Okay, so the question they're asking here is, why are EF and segment BC parallel? Well, this is using a construction here to create congruent angles. So this angle right here will be congruent to that angle right there. Okay? Because those are corresponding angles there. Likewise, these angles right here will be congruent as well. And then angle A, well, that's shared by all three of by both triangles that we create. There's a triangle right there that's got angle A, and the big triangle right here that's got angle A. Okay? So, right, so what's the answer for the blanks? Well, again, we've got EF, and these corresponding angles are congruent, right? And likewise, this angle here and this angle here, they're corresponding angles, and they are congruent. So how do you know they're parallel? Well, it's because, and I'm just going to do one example here, because angle AEF and angle ABC are congruent corresponding angles. Okay. Remember that the parallel line kind of theorems work in both directions. So for example, if you have parallel lines, then corresponding angles, alternate interior angles, alternate exterior angles are congruent. But if we have corresponding angles, but backwards too, if corresponding angles are congruent, so if we know that these two angles are congruent, then we also know that EF and BC must be parallel. Okay. All right, I guess we can actually measure this here and see this. So let's see. I'll measure it here using my ruler so we can kind of see this. All right, so it says use a ruler to measure AE, EB, AF, and FC. And so if I do that, let's see here. So if I measure AE, I get about, I'm going to say about 0.8 centimeters, I think. Okay, there's E to A. So 1, 2, 3, 4, 5, 6, 7, yeah, 8 we'll say from E to A. Okay, so we'll say AE is about 0.8 centimeters. Okay, and we'll check EB. Bless you. And that's also about 0.8 centimeters. So this is about in the midpoint here. All right, and we'll check AF as well. So from A to F, we have about, we'll say, 1.2. I know AF has a different meaning for you guys, but we're going to keep it PG here in geometry class. All right. And then FC is, we'll also say about 1.2 there. Okay. Oof, and I'm being very generous in my measurements there, but that's okay. Okay. So we kind of measured some things, and then it says, then compare the ratios AE over EB to AF over FC, okay? So AE is 0.8 over EB, 0.8, and then AF is 1.2, and FC is 1.2. And if we simplify that, 0.8 over 0.8 is 1, 1.2 over 1.2 is 1. So the ratios here are the same, okay? The ratio of this piece, AE, over this piece, EB, is the same as the ratio AF over FC, okay? So you might not be, so why is that important? Why is that, how is that different? How is this different than the triangle similarities that we've shown before? What's different here, okay? The key is this. Before, when we were doing our similarities, we were comparing entire sides of a triangle to entire sides of another similar triangle. So for example, before, all we were comparing, for example, was AE, which is a full side of the smaller triangle, to AB, a full side here. Likewise, before we were comparing AF to AC, the full side there. Or we would compare EF to what other side? BC, okay? Because that's the full side there. But now, with the way we've constructed this, we're comparing AE, which is a full side, but we're not comparing AE to AB. We compared AE to BE, okay? That's a different kind of ratio. We also compared AF, not to AC in this case, which you could because they're similar. We said AF over FC, okay? So those ratios are a different kind of flavor of ratio than what we've been seeing, okay? So let's continue on here. All right. How can you show that triangle AEF is similar to triangle ABC? Well, it's similar by angle, okay? So we know that. So on the next page, sorry, on number 1 there, how can we show that the two triangles are similar? Well, the two triangles are similar are similar by angle. Okay? All right, that's it. Next question is, what do you know about the ratios AE over AB and AF over AC? Well, if we go back to look at our picture, okay, AE over AB, how does that compare? Are they equal to AF over AC? How do these two ratios compare? They should be what? Yeah, they should be equal. Yeah, AE is a full side of the smaller triangle over AB, full side of the big triangle. AF, full side of the smaller triangle over AC, entire or full side of the big triangle. So yep, they should be equal. Okay. So what do you know about the ratio? These two ratios, they should be equal. Or the ratios should be equal. Okay. Because triangle AEF is similar to triangle ABC. Okay? If those two triangles are similar, then those ratios should be equal. Okay? So that's the idea. And so we're not going to worry about number 3 because that's going to be what we're going to learn here next. Okay? It says make a conjecture. Use your answer to step E and make a conjecture about the line segments produced when a line parallel to one side of a triangle intersects the other two sides. So, when we scoot on down here, we will see the triangle proportionality theorem. Okay? And so here it is. If a line parallel to a side of a triangle intersects the other two sides, so here's this line EF, it's parallel to side BC, okay? And it's intersecting this side of the triangle and this side of the triangle, okay? It divides these two sides that it's intersecting proportionally. So AE over EB is the same as AF over FC. Okay, we can set up that ratio there. Excuse me. Okay? That's the idea. All right, so let's see that kind of in action here. So we're going to skip this proof. We're not going to do the proof. Skip over to page 633. Okay, and we'll look at this example, explain 2, okay, which is an example. Find the length of each segment, it says. Okay, so we want to find the length of CY. So if we go to our picture here, here's the length CY. This is what we want to find. I'm going to call it X, even though we kind of already have an X point there, but that's okay. Okay. Now, you can see that we have this big triangle, and we have a line parallel to one of the sides of that triangle intersecting the other two sides of the triangle. Okay, and so that cuts the two sides into the same proportion. So 9 here is the part, and that matches to the other part of that side that's being cut by the line there, so 4. So we can say 9 over 4 has to equal, and then what other ratio here? Well, the 9, this piece, is going to match up to the 10, this piece, over the X, which is that piece right there. So there's our ratio. Okay, this is a different ratio than the ratios we've been setting up prior to this. Okay, 4, right, is not an entire side of any triangle. 4 is a piece. X is also just a piece of a side. It's not an entire side. Okay, 9 is an entire side for that smaller triangle. But there's a ratio. So let's set it up here. Let's cross multiply, right, so we can solve it the normal way. 9 times x is 9x. 4 times 10 is 40. And what's our final step here to solve the ratio? Divide by 9. This does not divide evenly, unfortunately. So let's see here. 40 divided by 9 is 4.44444444444. Repeating. Okay. 4.4 repeating. Okay. Questions on this? Alright, so let's try another one here. I'm going to call on someone for this one. Alright, so in letter B, it asks us to find the measure of Pn. So here's Pn right there. We don't know that, so I'll put an X there. Okay, and let's go to Donovan. Alright, Donovan. So, again, we've got PQ, okay, which is a line parallel to LM. So this line PQ here, it's cutting these two sides into proportional pieces. So the X would go over what number? The X, sorry? So you could put it over the 5 here. That would actually be okay. If you did it that way, you would say X over 5, and then what would be your other ratio you want to write there?
2 over 3.
Careful. We said X over 5.
Okay, yeah, 3 over 2.
There you go, 3 over 2. That's right. So that's one way to set it up, okay? Now, that's not the way I was showing you guys earlier, but this way does work. Let me show you the way I was going to show you. So just real quick there, Donovan. The way the theorem works, it's supposed to be X over 3, so the part over the other part of that same side. So X, this part over the same part side, should equal then 5 over 2. Now, Donovan, the way you set it up, though, it will still work okay. Okay? But this is the way that we were going to do it using the theorem. But you're not wrong what you did there. That still works. Okay? So let's cross multiply here. 2 times x is 2x. 5 times 3 is 15. Okay? And then divide both sides by 2. And you get x is 7.5. Okay? If you notice here, this other way of, well, so there's that. Okay, so questions on that one? If you notice this other way that I set it up here, what will it result in? If I multiply 2 times x, I get 2x. If I multiply 3 times 5, I get 15. So it's going to end up being the same exact thing. I got 2x equals 15, so that means x is still going to be 7.5 there. Okay? So there's more than one way to set this up. More than one way to set this up. All right? But you can't set it up in just any old way you want to, though. We can't just say random number over random number. You can't just like pick any numbers and just make it up. You have to, pick matching parts. So x over the 3, 5 over the 2. Okay. Questions on any of that? All right, let's try another one here. Right, we'll do one more together, and then I'll have you guys try one here on your own. All right, so let's try number 5 together, and then I'll have you guys try number 6. Okay. So number 5, we want to find the length of DG. So there's DG. We'll put a little X there because we don't know it. We want to find that. All right, and we'll go to Jake. Jake, what's the ratio we can set up here to find DG? What do you say? Yes, good job. Okay, 40 over X. So again, we have parallel sides here. This parallel line CD, is cutting these two sides of the triangle into proportional parts. So Jake correctly saw 40 over X is going to equal 32 over the 24 there. Okay? And then now we know what to do, right? Everyone here should be fine with this. We cross multiply. And we get 960 equals 32x. And then last step here, Jake, what do we do to both sides? Divide by 32. You got it. So x is 30. Easy. No decimals or anything. Okay. All right, go ahead and try number 6. Try number 6. Try number 6. Okay, so take a minute. Try number 6. Solve for that missing RN. Yeah, this one you're going to get a decimal. Sadly. Okay. See how we're doing here. So go ahead, set this ratio up and solve. Okay. You need a calculator, Tristan. You said no? You do? Hey, you want? Yeah, that's right. You said 10 over the 8. What? Equal then. There you go.
What's your thought? You did whatever what?
Okay, yeah, right, so, what you get here?
Tell me why you didn't put 8 over 10. When I look up there right away, I think, oh, 8 over 10.
So you then
Tell me why not.
10 over that. So 5 over 8 is doing that X.
You're nuts.
Same kind of pattern.
It's cool because you and I think it's a really different way. There's something You're crazy, right?
It's not what I'm showing you guys, but it still works. Like, you know what I'm saying? Like, I'm trying to show you one way to do it, so that's the way.
How did you set this up?
So you can read the lyrics.
10, 5 over 10.
I have 5, that's my answer, 5.
And then
5 over
combine
5.
two, and then.
Huh? No, but what? You did 10 twice.
Yes.
So it should be 5 over what? Not 10, but, yeah.
Okay. That's it. Yep.
Okay, make sure you're following along here, Blake. All right, folks.
You're out of control.
6.25 is what you should have gotten there. Okay. Now, I want to point something out here. You guys did a great job. I saw a lot of different ratios, and that's fine. But my only concern with all these different ratios that we're writing, okay, is that, you know, I hope we're not just guessing, okay? Because I saw some other people write the ratios in the wrong way, too. So remember that with these ratios, it's not kind of like reading around the problem. Like, you don't want to say 5 over 8 equals 10 over x, you know. You want to say 5 over x equals 10 over 8. You got to be careful how you do this, okay? You want to match up pieces. So 5, okay, and the 8, they're both parts of the same side. So that's why I made them together, right? 8, I put over the 5. I could have just easily said, 5 over 8. That's fine. Again, they're parts from the same side. Equals, but then if I write 5 over 8, how do I have to write the order of this ratio here? I have to write x over 10. Okay, 5 was like the right part over 8 the left part, and so x is the right part of this side over 10 the left part of that side. Okay, they're kind of, 5 and x are kind of like in the same position, so they need to be in the same position here. 8 and 10 likewise are in the same position, so they need to be in the same position down there. Okay, so you can set them up in different ways, but not every way works. We have to be careful, and I don't really have a good way of describing it other than make sure you're just setting up ratios of matching parts. I want to say one more thing here too before we move on. We can actually do this the old way, okay? So we can actually do this the way we did before with other ratios. If we stop thinking about this as being parallel sides and then just do part over part equals part over part, we can actually do this using similar triangles, okay? If you look at it this way, we have a triangle right here, right? There's a smaller triangle, and we have this bigger triangle right here, and they're similar. But how we set up the sides? Well, this side of the smaller triangle, right, that's 8, so that's easy. So let me kind of like do this in a separate thing here. So we have 8, okay? Right, it's like the warm-up. Exactly right. Thank you, Ms. Bachman. That's a good point. It's just like the warm-up. So 8, right, that matches up to this full side here of the triangle. What's the measure of the full side here? 13. So we'd write 8 over 13 equals, and now I need another side of the smaller triangle. Well, here's 10, right? So 10 over, what's the full side of the big triangle here? 10 plus x, yes. 10 plus x is the answer, okay? Do you see that? 10 plus x, or 16.25, is that what you're going to say? But that's already knowing the answer, right? We're still trying to figure it out here. I think you're saying you're not wrong. That's correct. Okay, that's correct. But we're going to try and find the side. We're going to pretend like we haven't found the side yet. So we cross multiply here, 130, and then cross multiply here. 10 plus x times 8. What does the 8 multiply with here? The 10 and the x. Yeah, so it's going to become 80 plus 8x equals 130. Now you might look at this and say, Mr. Woodmeyer, there is no way that this is going to solve and give us 6.25. But just wait and see. We subtract 80 from both sides. We get 8x equals 50, which is exactly what we had before. 8x equals 50. And when you divide both sides by 8, x is 6.25. Okay? So we get the exact same answer using our old method. So we don't really even need this new theorem. We can still use our old method if you want to. So if you want to just stick with like what you know, the old method there, that's fine. You can just do full side of the small triangle, 8, over full side of the big triangle, 13. 13. And you can do full side of the small triangle, 10, over full side of the big triangle, 10 plus x. And you just cross multiply and solve, you get 6.25. That works. Soon. Okay? All right. So it turns out that you can also do this proportionality theorem in reverse. So if you look at this next one real quick, if you have a line that goes through two sides of a triangle, and if that line creates equal proportions there, then you know these two lines will be parallel. Okay, so if we go here real quick, we'll skip over. Yep, we're almost done here. This will be like the last example. Thanks. So page 635, sorry, I'll zoom out so you can see. Page 635, now this is our last little example we'll look at. Okay, the example here is we're going to verify that the line segments are parallel. So that means we want to set up the ratios. If the ratios are equal, that means then that the lines are parallel. So let's set up these ratios here. Okay, so let's go to Eli. So Eli, in this situation, we want to verify that MN is parallel to KL. So what should the ratios be that we're going to check here? What over what can we match up here, Eli? Say it again. 42 over 21. Piece over piece. And we want that to equal what? Beautiful, exactly right. 30 over 15. Okay? So do these two things equal each other? And so, Eli, how would you determine whether these two things equal each other? What would you do here? Cross multiply? Yep, that works. Fine, we'll do it that way. Okay, and they do? 630? Okay, so there you are, folks. Those two ratios are equal, so what can we conclude? What's true about Mn and Kl then? They're parallel. Exactly right. Well, they will be proportional too. They will be proportional too, but we're trying to verify that the line segments are parallel. So Mn is parallel to Kl. Okay, must be. That's our conclusion. So again, different set of directions. We're kind of going backwards. Before, we were told these were parallel and then used the relationships to solve for parts. Now we're saying, well, we don't know these are parallel. Set up the ratios to see if the ratios are equal, and there they are. So that means their lines are parallel. Okay. Last example we'll do together, and then I'll have you guys try one on your own. Okay. So we're going to do two more problems here, and I'll go start on the homework. Letter B. We're told that we want to determine if. Sorry. Yeah. 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 I know. You know, figured a little something. It's Friday. That's right. That means you have extra time to do your homework, or in some people's cases, extra time to procrastinate the homework. I'm not going to say any names. I don't want to get anyone else. I want to try and burn anyone else today. Okay, so I'm not saying it's Josh. I'm just saying I want to insult anybody else today. I didn't want to do it like I did. I'm mad I did it yesterday. Not sad I did it yesterday. So anyway. Shh. You know who you are. Anyway, I'm not going to say names. You know who you are. All right. So we're told that AC is 36 centimeters. So that full side there is 36. BC. Full side, 27 centimeters. Okay. So now this is slightly different than what we had before, isn't it? Because before we had the individual pieces and the individual pieces. But now I've got a piece here, but I don't know this length. Listen up, please. And then I've got this piece right here, but I don't have this piece right here. So, how can we get that? Let's go to, someone who's here. Courtney, what do you say? So, Courtney, I've got the full length here, AC. I've got this length, DC, which is 20. How can I figure out what this measure is right here? So, well, we can figure it out, though. No, we don't need to set up a variable. Again, if I've got the full length here is 36. This length is 20. How can I figure out what this length then must be? You got it. 36 minus 20. So I'm going to do that in my head. It's 16 centimeters. Okay. And then likewise, Courtney, how can I find the length of BE? You might want to look at my picture because I don't think you have it marked up there. Again, the full length is 27. This piece is 15. So what's that piece got to be? So, not necessarily 16. How do we get it? Again, the full length is 27. This piece is 15. How can we get this right here? Yeah, 27 minus 15, which is 12 centimeters, Josh. Exactly right. Very good. Okay. Okay. So, now we've got those pieces, we can set up our ratios. So, Josh, do you want to set up our ratios for us here? 20 over what? Okay, so we could say 20 over 15. That's one way to set up the ratios. Okay, we can say 20 over 15 have to equal then what?
16 over 12.
Yep, that's one way to set it up. Okay. So Antoinette, yeah, the one I was looking for, and this. So Josh, you're not wrong. But again, the one I'm encouraging you to use is the part here 20 over the other part 16. Okay, equals then what's the other one, Antoinette? Sorry.
15 over 12.
15 over 12, that's right. Now, if you look here, though, it's going to end up being the same thing. If we cross multiply, it's going to end up being the same. We're going to do 12 times 20 in both cases. We're going to do 15 times 16 or 16 times 15 in both cases. So we get 240 here equals 240. Okay? So, Josh, is DE parallel to AB then?
No. Yes.
How do we know?
I don't know.
Yeah, I know you don't, so that's why it's important to pay attention, okay? So here we go. Someone want to help Josh out, please? Why do we know these two lines are parallel? Jordan, well, you're silent. Hang on, we'll go to Debbie, I know. Yes, the two ratios, Josh, here it is, pay attention. The two ratios are equal. When you cross multiply, you get the same number, and so therefore DE must be parallel to AB. That's the key, okay? That's how you know. All right, try number 9, please, real quick. Verify that TU and RS are parallel, okay? Set up your ratios. I'll get to you in a second here. I understand. Did you have a question, Tristan? The answer for which one?
It's 240 equals 240.
Yes, if you wouldn't mind. Are they coming around right now? Yeah, if you wouldn't mind. Please. The people who do recycling. Yes, sir. Yes, I'll give you some credit.
Okay, that's good. That's one way to set it up. Yes. This is the correct way to set it up. So the way I was trying to show you guys, and again, you're not wrong. This is not wrong. 90 over 67.5 equals 70 over 54. That's right. What I was trying to show you today was 90 over 72. Part over part. But either way,
Is that just for parallel?
that's just when we're trying to turn it parallel.
Okay.
Yes, that one will be starting there.
I'll get you the assignment here in just a second. No, not what I wanted. Bless you. Okay. Okay, folks, we ready? Let's go over this real quick here. So let's go to Robbie, please. What are your ratios you set up here, Robbie, for this prop?
72 over 54 equals 90.
72 over 54 equals what?
90 over 7.5.
Okay, and you cross multiply, right?
Yeah.
And what'd you get?
4,860.
Okay, 4,860 equals 4,860?
Yeah.
You'll notice my ratios are slightly different. Again, Robbie's was not wrong. There is more than one way to set this up. I did 90 over 72 equals 67.5 over 54. That also works. Also gives you 4,860. Yeah. Yeah. You'll end up getting the same number. It doesn't have to, actually. You could have easily done 72 over 90 equals 54 then over 67.5.
So, if those two numbers are not the same, we just write it.
Right, then they're not parallel. These would not be parallel. But since they are equal, these two segments are parallel then. All right, folks, that's it. Let me give you guys your assignment.